Hello guys, hi, good evening, good afternoon. So hope everyone is doing great. Hi guys, welcome to the class. So in today's class we'll be discussing about the derivation of electric field due to a dipole and electric potential due to a dipole and the presence of dipole in an external electric field. What happens when a dipole is present in an external electric field? So we'll be studying those. We'll be discussing those and we'll solve few problems based on what we have studied. Yes, hi, good afternoon, Prajwal. Yo. So, hi, YouTubers. Hope everyone is here. So, hope everyone are enjoying your studies and enjoying your holidays. Yes. Uh, yes. Hi, Arun. Yep. So, guys, how many of you are feeling that you are present in your yeah, actually you are present in the class today, you're attending the class, but what's happening, your attendance is not getting registered because maybe you might have given us the wrong email id, or you might be using a different email id which is not the one which you have given to us, right? So Arun, please check that. If there's any issue you could contact me. Okay. So hi guys, let me know if my voice is audible clearly and if my screen is visible to everyone. Okay guys, I hope everyone tried to find, yeah, try to find the electric field due to dipole yesterday. Did you try, guys? Did you try to find the electric field due to a dipole? Hmm. Yes guys, hi. So is my voice clear to you guys? Any instruments? I don't know why I feel like it's lagging a bit. It shows internet unstable in network. Okay, cool. Thank you. So guys, thank you. So cool. Um, okay, goes. Hello, guys. Hi. Good afternoon, guys. Okay, please try to call your friends who are available. Like, yes, if they are available, please call them to the class. So I don't know why the strength is getting decreased day by day. So okay, most of you have this doubt, sir. We are attending the class, but in attendance I'm getting absent. So the problem is, guys, as I told you earlier, see the attendance, for attendance, whatever you have given the email ID for us in Zoom as registered email ID, you should use the same Gmail ID. Otherwise, we can't track your attendance. So your attendance is tracked using your Gmail. Okay, and that's it, Mega. So hi guys. So I'm going to end this poll. So yes, all of you have given me yes, I'm audible and visible. So guys, let's quickly start with our derivation. So I hope everyone tried to derive this equation. Yes, click on yes if you have tried, and if you have got. Hi guys, please click on yes if you have tried and got this derivation. So what happens in here, guys? So tell me what happens here. Hi YouTubers, please try to answer, try to be active. So what I have here, we have a positive charge here and we have a negative charge here. Now this is a dipole. The magnitude of the dipole is always having same magnitude, right? Both the dipoles, the charges of both the charges have magnitude q, right? The magnitude of both charges is q and is separated by a constant distance of 2a. Now I'll consider a point r at a distance small r from the center, from the midpoint of the dipole, from the midpoint of the dipole. Okay, I'll consider a point r, capital R, from the midpoint of dipole of length small r. Now, what is the, yeah, what do you think the electric field E plus Q will be in the electric field due to charge plus Q will be in the leftward direction, right? Am I correct? Cool. Thanks, bro. You. So yeah, the electric field due to the point charge plus Q will be in the leftward direction. Similarly, since okay, I'll assume this is a positive test charge. Again, this is a positive test charge situated at capital R, point capital R. Now, because of this dipole positive charge, the electric field at capital R would be in the leftward direction. Similarly, why is it in the leftward direction, guys? Tell me. Why is it in leftward direction? Why is it in leftward direction? Answer. Yes, because these two are positive, right? They tend to repel. That's why. Now, if you see, yes, again I have this test charge, positive test charge over here. Now, the electric field between the minus q dipole and the plus q dipole. Here, yes, in this direction towards right, because these two dipoles, I mean this test charge, the test charge and the dipole charge, negative dipole charge, are attractive in nature. So now guys, what happens to the net dipole? I mean, sorry, what happens to the net electric field? What happens to E net? What is E net? Tell me what is E net, how to find E net? Hi guys, come on, be active. How to find E net, net electric field? E is equals to, try to be active guys, come on. The net electric field E net is equals to, yes, addition, vector addition of these two electric fields. Yes, correct, Dhanush. So it is E plus Q plus of E minus Q. Now what is E, guys? What is electric field E? What is electric field E in general? Yes, correct, Karthik Gowda. E is equals to, yes guys, come on, tell me what is E? Force upon charge, right? Force upon test charge. What is force? Coulomb's force. From Coulomb's law, what is force? What is my force, guys? K capital Q small q by R square divided by Q. Now these two cancels. My electric field E will be given as KQ by R square, right? Now if this is the electric field, then what are these expansions? Expansion enta agate heli. Yes, correct, Ramakrishna Reddy. Correct, Girish. So what happens to the expansions of these? Yes, what's the next step, guys? So we get E is equals to minus Q by 4 pi epsilon naught. Okay, what have did here? What did I do here? Q by 4 pi epsilon naught is fine. Okay, this is nothing but K, Q, and what is R, guys? From here, what is R? What is my distance R? I know E is equals to KQ by R square, right? E is equals to KQ by R square. Now, what is my R here? The small r was the distance between which and which? The first charge and the second charge. So I had two charges, the source charge and the test charge. Now distance between these two, if the length from midpoint of this dipole from point C to point R is small r, if the midpoint, if the distance between the C and the point R is small r, then what is this distance, guys? Tell me what is this distance? What? How much is this distance? Answer, guys. Come on. Yes, correct, Prakash. It is R minus A. Wow, this is R minus A. So R minus A. Right. Then what is this direction, guys? What is this length? From here to here. From here to here. Between the point and this point is, yes, R plus A. Correct. R plus A. Now, yes, we got the distance between the respective charges. Now we'll apply that. So we get E is equals to Q by 4 pi epsilon naught R minus A whole square plus of minus Q by 4 pi epsilon naught R plus A whole square. So we took the magnitude of charges. So what happened? I have skipped one step here. That is I've taken the q common and 4 pi epsilon naught also common in both the cases. Now guys, you got this much. What is p cap? What is this p cap for? What do you think that p cap is for? Yes, correct. Irish. Correct, Ramakrishna Reddy. Yes, correct, Devika. Yes, correct, Karthik. Awesome. Yes, Suprita. It's a unit vector. What is p cap? P cap is a unit vector. What does this do? What is the significance of using p cap, guys? What is the significance of using p cap? It gives what? What information does p cap give? Yes, it gives the direction of dipole moment, or it gives the direction. Actually, here p cap is nothing but magnitude of p into p cap, right? So p cap is always from minus q charge to plus q charge. It's the direction of my dipole. But here it also gives the direction of electric field. In this case, in this derivation, this p cap is giving the direction of electric field. How? We know the direction of p cap is from minus q to q. So which of these charges is acting in the leftward direction from minus q to q? The direction of electric field due to positive charge, right? Yes, this one. So this is in p cap direction. Now this is acting opposite to this. See, the electric field between minus q charge and the point is acting opposite to it. So I get the negative of p cap. Hope everyone got this. Or I can also take this way. I have taken q by 4 pi epsilon naught into r. So the q had a magnitude of negative sign here. So that negative sign is given to this. Yes. Guys, what is the magnitude of p cap? What is the magnitude of p cap? Yes, it is 1. Right? Correct. So it's a unit vector. It's only for direction. So p cap is a unit vector. It's a unit directional vector along the direction of dipole moment. Right? Correct, Devika. Correct, everyone. Cool. So which formula did I use here? I'll write down that E is equals to KQ by R square. This is the formula which I used here. Next, guys, next step. What is the next step? What happens next? So in order to find the electric field, what should I do? Tell me. What should I do? You should, guys, reply. You should help me solve this, please. Yes, correct, Devikanani. What should I do to solve this? Next step. Next step, Haley. Please help me solve this. Yes, simplify how? How to simplify? Yes, correct, Anusha. We have to take LCM, guys. Everyone take LCM. Take LCM. Yes, even that is possible, Dhanush. Yes. Yes, even that is possible. So take LCM. Simplify by taking LCM. What we get? What do we get? We get this expression. Okay. So what happens? I have expanded. What in this step? What I have done? I have done the expansion of r plus a whole square. What is r plus a whole square? It's r square plus a square plus 2ar in p cap direction minus of r square plus a square minus 2ar in p cap direction. So I have expanded both of these and cross multiplied. And what happens in the denominator? They multiply themselves. So what's the next step, guys? What happens here? When I multiply this negative sign into this, what happens? What happens when I multiply this negative sign into this? Yes, correct, Girish. So yes, I'll get correct. Correct, Prajwal. Correct. Dhanush, check your answer. Prajwal, correct. Dhanush, check your answer. Okay, okay. Sorry, Dhanush. Even correct. Dhanush is also correct. Cool. Okay. So I'll try to simplify. What happens? My r minus r and plus r gets cancelled, and minus a square and plus a square gets cancelled after multiplying my minus here. After multiplying minus here in both cases, these two magnitudes cancel. This becomes plus 2ar. So 2ar plus 2ar becomes 4ar in p cap direction divided by a plus b into a minus b. Guys, this is a plus b into a minus b. That is nothing but a square minus b square. Again, I have whole square in this case. A plus b into a minus b whole square was given. That is a square minus b square whole square. Yes. A plus b into a minus b whole square was given, or a plus b whole square into a minus b square was given. That is a plus b into a minus b. That is a minus b. Now, if we have considered one condition, so if we don't consider my A is very smaller than R, guys, what is A? A is nothing but distance between one of the dipole and the midpoint, right? If that is very short, very short, what can we call this dipole as? If length of A is very small, what can we call this dipole as? So when my A is very small, A is small, we call that as a small dipole, okay? Having very least distance between them. Next, what happens if we neglect A? We'll get this step as we get 4qa in p cap direction into r divided by 4 pi epsilon naught r power 4. So that we get as 4qa in p cap by 4p. So what happens? One of my r from numerator and r from denominator gets cancelled. Then I get this expression. Now rewriting 4qa as 2q into 2a, we get 2a as p cap. Okay, 2a as, it's not p cap, sorry, this is 2a, 2q into 2a will be given as, okay, this is nothing but my q into 2a will give me, yes, this is not the answer, it's q into 2a gives me what? P. Q into 2a here, q into 2a is nothing but my p. Not only 2a, q into 2a will give my vector p. Okay, so 2 into q into 2a gives my vector p, that is 2 times of p divided by 4 pi epsilon naught. So guys, I hope all of you have got this derivation. I hope all of you have got this derivation. So this is a derivation for electric field due to a dipole on the axis. So this is on the axis condition. Yes guys, got this? Please click on S. Yes, correct, Ramakrishna Reddy, correct, Devikanani. Cool. So yep, let's move on. So what happens? What do you observe from this, guys? What do you observe? I want you guys to answer. Guys, take a minute of time. What do you observe from this expression? What do you think is happening in this expression? Electric field due to a dipole. What are the changes compared to point charge? So comparing with a point charge, what do you observe? I want everyone of you to answer this. I want everyone to answer this. Come on, answer. So if you compare the electric field equation of dipole and that of my point charge, what is the expression for point charge, guys? E is equals to q by 4 pi epsilon naught into r square, right? What's happening in this case? This was my electric field due to point charges, 2 point charges. And what's happening in the dipole? Here, draw. Hello. So if my electric field due to dipole is 2p by 4 pi epsilon naught into r cube, then is okay. It is the expression for electric field due to dipole in the axis. Now, what I want you guys to do is so compare it with electric field of point charges. So what is the difference between that? Okay, 2p by r is multiplied. Yes, correct. So q is equals to 2p by r. How the judges are thick. So what can you say? What can you conclude about the electric field? So if you want to try to compare what happens, I can take all other things as constant. Nodi, observe this. So my electric field due to dipole is proportional to 1 by r cube. Can I write this? My electric field due to dipole is 1 by, is directly proportional to or inversely proportional to r cube. Guys, observe this. My electric field due to dipole is inversely proportional to r cube, but my electric field due to point charges is inversely proportional to r square. Right? Correct. So what can I conclude here? In which point or in which case does my electric field fall the fastest? In which of these two cases does my electric field falls the fastest? Answer, guys. Come on, YouTubers, try to answer. Yes. Correct, Ramakrishna Reddy. Correct. Yes, Prajwal. Prajwal, no. Dhanush, no. I asked. Okay, guys, come and tell me. Yes, correct, Tejas. In which of these two cases, in case of dipole or in case of point charge, does my electric field falls the fastest? ಯಾವ ಕಂಡೀಷನ್ ನಲ್ಲಿ ನನ್ನ ಡೈಪೋಲ್ದು ಎಲೆಕ್ಟ್ರಿಕ್ ಸಾರಿ ಯಾವ ಕಂಡೀಷನ್ ನಲ್ಲಿ ನನ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಜಾಸ್ತಿ ಕಡಿಮೆ ಆಗುತ್ತೆ? So in which condition does my dipole in which condition does my electric field reduce the fastest or decrease the fastest? Yes, guys, correct. So in case of my dipole, my electric field reduces the fastest. How? So comparing that with electric electric field due to point charge, we get the expression for the electric field falls as 1 by r cube in case of dipole. Compared to single point charge, the electric falls the fastest in case of dipole. Okay, correct, guys. Super awesome. So yes, it's inversely proportional. Electric field. So if my r cube, so what happens if my r cube decreases? See, whenever I see always why did I give this statement? If my r will be always less or more. If my r is very less, say about 10 centimeters. In meters, how much is it? In meters, how much is it? 10 centimeters. In meters, how much is it? 0.1 meter. Am I right? In meters, 0.1 meter. So what about r square? When r square happens, right? So if R is very less, what happens to the electric field? It increases more, right? If my R is decreasing, my electric field will increase. Hoda? Correct? If my R decreases, my electric field will go high. But in this case, what's happening? If my R, yeah, if my R is increasing, what happens to the electric field? What happens to the electric field? If my R is increasing, my electric field will go low, right? So in case of my electric point charge, in case of point charge, when my R increased, in case of point charge, when my R increased, the electric field decreased in terms of R square, right? In case of point charge, when my R increases, my electric field decreased as square of R. Howda? But in case of dipole, when my R increases, my electric field decreases in terms of R cube, right? So which is more? Which is decreasing more? When my R increases, which is decreasing more? My dipole or a point charge? Electric field due to dipole or electric field due to point charge? Yeah, because of electric, yeah, my R as R increases, yeah, I'll write in words, increases, the electric field E decreases in both cases, but decreases fastest in dipole. Decreases in both cases, in electric in point charge also, in dipole also, but decreases fastest in case of dipole. Okay, so that's what I wanted to convey. Next, guys, if my a is not if my a is not negligible, or if r is almost equivalent to a. See, I want to say, if my r is almost equivalent to a, then what happens? We have to use this equation. Okay, in case of short dipoles and short distance, we have to use this equation. Okay, okay, this expression we have to use in case of short dipole or short distance. It should be short distance also. So if my point is at a very small distance, if my point is at very short distance, then I have to use this formula. Okay, yes, guys, got this? Artha ಆಗಿದ್ಯಾ? Please click on yes if you have got this. Yes, ಮುಂದೆ ಹೋಗ್ಬೋದಾ? Can I go further? Can I go further? Yes. Cool. Come on, guys. Then I have a question for you guys. If you have understood this, try to solve this question. So who will solve fast? Let us see. YouTubers or Zoom people. So in case of Hariprasad, I didn't get your question properly. Yes, exactly. So we don't have that condition, Amit. So yes, guys, in the previous case, we don't have R equals to A. R equals to A is never, R is not equals to A. Okay. R will never be equal to A. Okay. So that is one necessary condition. Cool. So Hari Prasad, I didn't get your question properly. I didn't understand. Please try to elaborate. Um, Hari Prasad, can you rephrase your question, please? So please tell me if you are asking this. So your question says, sir, in case of 0.01 meters, electric field value is less than dipole. For same given values, so electric field decreases slowly. I'm confused with the question. So are you asking this if my electric field, so at 0 point, at R is equal to 0.01 meters, my electric field value is less than dipole. Cha, electric field due to point charge is less than dipole. Are you telling this? Yes, correct, Ramakrishna Reddy, correct. Correct, bro. Are you asking this question, Hari Prasad? Yes. Please let me know. I couldn't understand that question. Please let me know again the proper question. Okay. So guys, yes, I received only two answers in Zoom and one answer in YouTube. Guys, try to solve. Is it difficult, guys? So what's given here? What is given here? Two charges of magnitude Q is equals to 1 microcoulomb. Q1 is 1 microcoulomb and Q2 is minus 1 microcoulomb. Is separated by 1 centimeter. R is 1 centimeter. Now calculate the magnitude of electric field. What is the magnitude of electric field? E is equals to what? From at a point R equals to, sorry, this is A, right? A is equals to 1 centimeter, R is equals to 10 centimeters. So which formula you are going to use, guys? Please try to use the formula whichever you are most likely to use. It's left to you. Yes, and try to answer this. So they have all the necessary formulas given. I'm going to write both the formulas. E is equals to, yes, it is Q by 4 pi epsilon R cube, right? Okay, 2 P by R cube. This is one formula. And we have one more for general condition. It's E is equals to K by 4 pi. Hope everyone is trying to solve that question. Yes. ಆಗಿದ್ಯಾ ಎಲ್ಲರದು? Okay, you have these two formulas. Whichever formula you want to use, you could use. And I have got only 4 responses, guys. Come on. Why is this question difficult to you guys? Tell me. If it's difficult, we'll start solving. If you feel it's difficult, we'll start solving. If you feel it's easy, you have to solve this. If you feel this question is easy, you have to solve this and give the answer. Okay, come on. So whichever formula you are going, okay, which formula? Formula 1 or formula 2? Tell me this at least. Helva try to answer. So which formula are you going to use, guys? First one or second one? And why? Yes, we are going to use second formula. Cool. Awesome, guys. So why? Because it's a short dipole. Or yes, correct, Lavish. Lavish, correct. So Hari Prasad will take your doubt in the end, okay? Uh, Hari Prasad will take your doubt in the end. We'll discuss there. Okay. So we are going to take the electric field E is equals to Q by 4 pi epsilon naught. So guys, we are going to take the second formula. I'm going to erase the first formula anyway. We don't require this. Yes, we have to substitute all the values, guys. Come on, tell me what's the value. Help me solve. Yes, E is equals to, what is my Q? Q is 1 into 10 power minus 6. So what is 4 pi epsilon naught, guys? What's the value of 4 pi epsilon naught? Tell me. Here, hey, activate Rapa, please. Try to be active. Everyone, YouTubers, Zoom people, please. Yes, it's 9 into 10 power 9. 10 power plus 9, yes. Next. So what is the next thing? Next step is 4 into, okay, 4 into, what is A value? A is 1 centimeter, 1 into 10 power minus 2 into, what is my R? R is 10 centimeters, 10 into 10 power minus 2 divided by R minus A. So 10 into 10 power minus 2 whole square minus 1 into 10 power minus 2 whole square. So ಇದೆರಡರದು one whole square. So guys, ಇದನ್ನ you can simplify in any way you want. You can simplify this in any way you want. If you want, you can apply a plus b into a minus b formula also. If you want, you can use a plus b into a minus b formula, then square the term. So its simplification is left to you guys. Come on, tell me. So after you want me to simplify this, I can. But I want you guys to do the simplification. Yes, correct, Ramakrishna Reddy. Thank you. Thanks for the response. So I want you guys to simplify this. So it's just simplification. Guys, wait. Did we take? Okay, I think we made something wrong. See, these two are separated by 1 centimeters, right? See, if you observe a dipole, say we have taken. Hello, what happened? Guys, is my board visible? Okay. What happened? Guys, just a moment. Something happened. I am waiting for it to recover. Yes. Yeah, cool. Okay, guys. So it's now visible, right? Yeah. Cool. Thanks for the response, guys. So, no, some error with the laptop. So, yeah, all of you who have given me the answer is correct, guys. So, yes, everyone in the Zoom had given me the right answer so far. Cool. Thank you, guys. Okay. So, guys, tell me, how are you going to solve this? So, I think we made a one small mistake while taking values. So, what is the value of A, guys? What is the value of A? The value of A is not 1 centimeter. It should be A is equals to half centimeter, right? A is half centimeter. Yes, it's not 1 centimeter. So suppose, I don't know why I'm not able to use this space. So A is half centimeter, okay? So we'll try to solve, then we have to erase this too. This is half, okay? I don't know why I can't able to access that. So electric field E is given by, yeah, please help me. 1 into 10 power minus 6 into 9 into 10 power plus 9 into, yes, okay, cool guys, cool. Thank you. Again, guys, observe here. This 4AR, this can be written as 2 times of QAR. Can I write this 2 times of PR? Sorry, 2 times of, okay, P into R. Because of distance factor, you have said the dipole decreases. No, Hari Prasad. I told the electric field of the dipole decreases, not the dipole decreases. Because of the distance, the electric field due to dipole decreases, not the dipole. So electric field of the dipole only decreases. Okay. So please don't make that correction. I mean, don't get confused. Okay. So this is 2 times of 10 power minus 6 into 10 power 10 power minus 2 into plus 1. So this is 1 into 10 power minus 1. So yes, okay, your doubt is clear. Thank you, Arif, for confirmation. So it's, yeah, I have 1 into 10 power minus 2. What's happening here? So guys, I hope everyone have solved this. So you get 1 into 10 power minus 6, 9 into 10 power minus 10 power plus 9, 2 into 10 power minus 2, and what was one more? 10 into 10 power minus 10 into 10 power minus 2, right? I have to simplify all of this and try to solve this. So you get, yeah, 10, 10 square, 10 minus 2 into 0.5. I'll take, have squared this, guys, 100 square. So you'll get 100 into 10 power minus 4 minus of 1 by 4 into 10 power minus 4 minus 8. So try to simplify this. You'll get this as electric field is equals to, yeah, 9 into 10 power 9 into 2 into 10 power minus 6 into, yes, yeah, 10 power minus 3, divided by. So guys, if I try to simplify this, I'll cancel these two and make it this. Okay, then I'll keep it as square only. Otherwise, I'll keep this as square. 10 into 10 power minus 2 minus 2 whole square. Okay, try to simplify this. So what will you get? You'll get 10 power minus 2 minus 0.25. So if you try to square this, okay, again, if you try to square this, 4 and 110 power minus 2 minus 4, okay, try to simplify this, you'll get this 0.25 into 10 power minus 4. Yes, yeah. Then the electric field, you if you try to simplify, you'll get 18.1 into 10 power. Guys, yes. See, they have given in the question. Okay, they had given in the question. So it Bharat simplify Madi. You'll try to simplify and you'll get that. See, they had given the question. So two charges are separated by a magnitude of 1 centimeters apart. Okay. So they had given the question, Amit, they had given the question 1 centimeter. So dipole, what we know. So dipole is two charges of same magnitude separated by a distance of 2a. Right. Here 2a value is 1 centimeter. Then what is the value of a? A is half centimeter, right? Amit, HR. I hope you got this. Okay, guys. So if you guys try to simplify, you'll get yeah, just mathematical simplification. Try to simplify, you'll get option C as your answer. So you'll get option C as your answer. Okay. Next, we'll try to solve. Okay, we have to move on, guys. So we have to find what is the electric field due to a dipole on the equatorial point. Now, try to help me solve this, guys. So we'll consider two charges of same magnitude separated by distance 2a, and the dipole moment is from minus q charge to plus q charge. Okay. Now, what happens? I have to assume a point. So I have a point, there is a point r in the space which is at the midpoint. It's exactly at the midpoint of these two dipoles. Okay, it's on the equatorial plane or on the equatorial point. So this is my equatorial line, right? Equatorial line. In this equatorial line, I'll consider a point r. Okay, now what is the electric field due to these two dipoles at r? Guys, try to solve this. So if we consider the electric field due to positive charge on capital R, on the point R as E plus Q, and the electric field due to minus Q charge is minus EQ towards the direction of the minus Q charge, then what happens to the electric field? Guys, tell me. Guys, tell me what happens to the electric field. Where would I get my electric field, guys? Where would I get my net electric field? E net. E net tells you. Where is my net electric field acting? Please reply. So have 2 points. Say I have the yes resolving the vectors. Correct, Karthik. So we have to resolve the vectors to find the net electric field. Okay. So try to resolve the vectors, guys. So what would I get on resolving E plus Q? So when I try to resolve the E plus Q along y-axis, I'll get yeah along y-axis I'll get E plus QY. Along for minus EQ, I'll get a minus EQY. Now these two vectors on resolving. So these two, what happens here in this case, guys? So this is acting. These two are having same magnitude. These two E plus Q and E minus Q are having same magnitude, but opposite in direction, right? Electric field due to this plus charge and this minus charge is having the same magnitude but opposite in direction. What happens? So they get cancelled. Next, what happens to the x direction vectors? What happens to the electric field acting in x direction? So these two electric field, one if you could see here, this is the electric field due to plus q charge, and this is the electric field due to minus q charge. These two gets added up. So the y components of electric fields get cancelled and the x components gets added up. Now, what is the net electric field, guys? What is the net electric field? The net electric field is due to only x-axis, not I mean, x-axis quantities or y-axis quantities. Only x-axis quantities, right? Let's try to find the net electric field E. Yes. Now, guys, I want everyone to try to solve this, try to derive. If you know this, try to derive and let me know once you have done. Click on yes if you have already done this. Click on yes if you have already done this. The net electric field E is given by, yes, cool, awesome, guys. Most of you have done. The net electric field E is given by, yes, again, E is equals to E plus QX plus of E minus QX. So I'm going to add all the X components of electric field. I'm going to add all the X components of electric field. So what I'll get? So I'll get E is equals to E plus Q cos theta. Why? Okay, how did I get cos theta? Guys, how did I get cos theta? So if you remember, if you see in this image, I have this angle. I have this angle is theta. This angle is also theta. Since this angle is my theta, this angle will also be, I mean, since this angle is theta, when I when I extend this with the horizontal, this again makes an angle theta. Correct? Guys, correct? Yes or no? You know, please tell, give confirmation. Yes. See, if my angle electric field is in this direction, it makes an angle theta. Now, if I take its projection along a horizontal direction, If I take its projection along horizontal direction, what will this become? What will this horizontal direction become? I mean, electric field due to horizontal direction become? Yes, this is, what is this? E plus Q cos theta. Yes, E plus Q cos theta, right? Then, guys, if this angle is theta degrees, from the concept of alternate angles, you know alternate angles. So you studied it in your 10th standard, right? From the concept of alternate angles, if this is theta, what happens to this angle? This angle is also my theta, right? Now, what about the projection of this vector over here? What about the projection of that negative? What about the projection of this vector over here? Yes, again, this is also E of minus Q cos theta, right? Yes, guys, click on yes if you have got this. How we got the theta components, cos theta components. Okay, cool. So my net electric field is given as the summation of all horizontal direction electric field. So I get E cos theta, E is equals to, E net is equals to E plus Q cos theta and E minus Q cos theta. Okay. E plus Q cos theta and E minus Q cos theta. Next, what happens next? How to find the electric field, guys? Next, really. So next step, we take out the cos theta components outside. Okay. Now we take out the cos theta components outside. Now, guys, again coming back to this diagram. Coming back to this diagram, from this triangle, what is cos theta? Say, take any, okay, take this triangle. From this triangle, what is cos theta? Yes, correct, Devikarani. So from this triangle, what is cos theta? Oh my god. Okay, I didn't give the second direction, right? This is R. Yes, this separation distance is R. This is A. Then what happens to this, guys? It's R square plus A square, right? Now, what is cos theta, guys? What is cos theta from here? What is cos theta? Taking one of the triangles, what is cos theta? Want answer, guys? Come on, tell me. Yes, it's A by adjacent by hypotenuse, right? So I know this is my angle. This will be my opposite side, opposite to angle. This will be adjacent to angle, and this will be my hypotenuse. So cos theta is adjacent by hypotenuse. Adjacent in the A. Hypotenuse in the root of R square plus A square. So you got cos theta value. Okay. Now we'll substitute that value. Okay. So E is equals to E. Yes, correct, Prajwal. Cool. Thank you. So E plus Q plus E of minus Q cos theta. Now what we did, so we know the electric field E plus Q. E is equals to theta. What is E? Electric field E. E is equals to F by Q italva. From here we got K Q by, I mean, this will be a K Q by R square. But my Q, capital Q value is also small q, right? So I'll substitute that q by 4 pi epsilon naught, and r is nothing but r square plus a square, right? So E is equals to q by 4 pi epsilon naught into 2 by r square plus a square into a by root of r square plus a square. I hope everyone got this, guys, till here. Are you getting the, are you getting the derivation, guys? E plus Q plus E minus Q, both are having the same magnitude. So 1 E plus 1 E, I'll get 2 E, right? 1 E plus 1 E, I'll get 2 times of E. The value of E is Q by R square, K Q by R square. R square is R square plus A square. So R is equals to square root of A square plus R square, right? So if I square this, what I'll get? I'll get R is equals to A square plus, or R square equals to A square plus R square. Okay, the distance square. Distance square is A square plus R square. Hope all of you are getting it. Correct, Karthik. Now, what happens? 2 into Q into A. What is 2QA, guys? What is 2QA? This is nothing but my dipole moment P. P magnitude of dipole moment is given as 2QA, if you remember. So what can I replace this point with? Say we know how we got the minus P vector, dipole moment vector. We know how we got. Do you guys know how we got the dipole moment vector, right? Guys, dipole moment vector. See, in this case, in which direction is my dipole moment? My dipole moment is from my negative charge to positive charge. But where is my net electric field acting? My net electric field is acting in this direction. So, with respect to dipole moment, what should I consider my direction as? Minus P, right? That's what we have considered here. Okay. Now, yes, correct, Hari Prasad, correct, Ramakrishna. So now, if we consider R, if my distance of separation from the point to the dipole is much greater than the separation between the dipoles, then we can neglect A, then we can neglect A. So what we get after neglecting A? Guys, tell me. Derivations are like this. So there is, I hope all of you are solving at your end. ನಾನು ನಿಮ್ಮನ್ನ ನಂಬ್ತಿದ್ದೀನಿ. ನಿಮ್ಮ ಎಂಡಲ್ಲಿ ನೀವು ಸಾಲ್ವ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಸಪ್ರೇಟ್ ಆಗಿ ಪೇಪರ್ ತಗೊಂಡು ಮತ್ತೆ ಡೆರೈವ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. Are you guys doing it? Okay, cool. So I hope you guys are doing it. You're solving at your end. So then the electric field is given by E is equals to minus P by 4 pi epsilon naught R cube. Yes, correct, Karthik. Yes, I got only one reply from Karthik. So he has solved this. Any others who have got this, guys? Others, how many of you got this? Come on, guys, reply. Try to reply. How many of you got this answer? Yes, cool. Super. Prasad. Yeah. Yep, correct, Hari Prasad. Cool. Others, hope all of you tried this. Okay, cool, guys. So this is the expression for electric dipole on the equator. Dhanush, I didn't get electric field other than these axes. So one is on the axis and one is on the equatorial point. So we solved this for equatorial point, Dhanush. Okay. Okay, if you want any angle theta, if you are asking for any angle theta, oh yeah, it won't come. Any other angle theta again, you solve madbekagutte. We have to solve that. Try, will not come, sir. Okay. So the expression for electric field, even in this case also, what we get, the expression for electric field falls as 1 by r cube. It's, see, even in this case also, my electric field is inversely proportional to r cube. As my r increases, my electric field falls the fastest, right? In this case of dipole, my electric field, listen very carefully, guys, it's electric field which is falling the fastest, not in a dipole. So yes, that's what we have learned in this. So compared to single point charge, the electric field falls the fastest in case of a dipole. Okay, guys, everyone understood? Any doubts in any of the points, guys? Hello, guys, please reply. Hope everyone have understood, and if there is any doubt, please ask me. Yes, cool. Awesome, Ramakrishna Reddy, correct. So Devikarani, negative sign is missing. Please check that. Okay, cool, Girish. Okay, guys, then if you have understood this, try to solve this question now. So this is one good question where it will give you an ideology of how to apply. So which of the following plot best represents the variation of electric field along y-axis at a distance y from the center due to given charge configuration? So this part is a question, guys. This part here is also a question. So this is part of question. This graph is this is not a graph actually. Okay, representation is also a part of question. This is also a part of question. Don't think this is an option. But these two are options. These four are options. Try to solve this, guys. Take 1 minute of time. Try to analyze what could be the right answer. So the question is, which of the following plots best represents the variation of electric field along y-axis at a distance from the center due to the given charge configuration? So there is, what's the charge configuration given, guys? Check out. So I have 2 point charges. Say one is plus q and other is minus q with a separation of d. Okay. Now, how would my electric field along y-axis? Along y-axis means which one, guys? Which of the two derivations applies here? Along y-axis means axis or equatorial point? Along y-axis means axis or equatorial point? It should be equatorial point, right? Cool. Now try to solve this question. I hope all of you are trying to answer. So guys, please remember the equations for both the cases. Please remember the, yes, correct, Tejas. No, Tejas, check your answer. Yes, Prajwal, correct. Equatorial point is the right answer. Mega equatorial point is the right answer. But Tejas, your answer is incorrect. Please check that again. Guys, I need answers. Please try to answer this now. Even if it's wrong, it's fine. Please try to answer. Okay. No, Tejas. No, Amit. Check your answer again. No, Mega. Check your answer again. No, Dhanush. Check your answer again. No, Dhanush. Yes, Manju. Correct. Suprita, correct. Manju, correct. Suprita, correct. Guys, here, see, I want to give you one hint. Here, this means it goes up to infinity. Okay. Here, if there's a suppression, this means it goes up to infinity. Suprita, Manju, correct. Others? Dhanush, no. Check your answer. Mega, correct. YouTubers, are you guys trying to solve? Prajwal, no. Prajwal, check your answer. So guys, this is very important for you guys. You could get such questions in your exams, competitive exams. Obviously, there would be a question from graphs. Okay. See, this is similar questions. See, either you'll get questions from gravitation field for graphs. This is very important, guys. So you may get questions from gravitational field. You remember in your 12th, right? You would get examples or questions for graphs from gravitational fields or from electric fields. So there is no much difference between gravitational field and electric field here, right? Amit, correct. Prajwal, correct. So guys, this is just equatorial point. You just derive the expression, right? Just remember the equation. What is the equation, guys? Tell me. What do you think the equation is? Electric field E equals to. So far I got only 10 answers out of 20 plus. Okay, 30 plus students. Hima, check your answer. Lakshmi, check your answer. Devika Rani, correct. So E is equals to minus P by 4 pi epsilon naught into R cube. This was my expression, right, guys? So this expression for your reference. So what is P here, guys? Tell me what is P here? What is my vector P here? P is equals to Q times of 2A. So, or in this question, how could you apply P? P is equals to In this question, what is the value of P, guys? Capital Q into D, right? P is equals to QD. Okay. Now my 4 pi epsilon naught is a constant by R cube. As my distance, so what is R cube, guys? What is R? What is R here? R is along y-axis, right? R is along y-axis. As my y-axis term increases, what happens? Analyze. As my y-axis term increases, what happens to electric field? So you have to analyze for three conditions. R is equals to 0, R is equals to some point n, and R is equals to infinity. You have to analyze these 3 points, guys. Always, whenever you get any question for gravitation field or electric field, always check for these three conditions in graph. Guys, I hope everyone is listening. This is very important. Whenever you get a graph, you have to analyze for these three conditions. Try to analyze for these three conditions. R is equals to 0, R is equals to n, n means any point, R is equals to infinity. So what happens when R is equals to 0? So I said R can never be equal to 0. Okay, the R can never be equal to 0. Okay, yeah, if R equals 0, it goes to infinity. R can never be equal to 0. Then R is equals to n and R equals to infinity. When R equals to n, what happens, guys? Yes, if I consider R equals 0, then answer would be infinity. Okay, guys, let's check the answer then. I'm going to end the poll. Okay, cool, guys. So the answer is yes. So try to recall this, guys. So recalling. So what's given in this question? What is given in this question? So given that D is not negligible, so in this case, this formula is not at all applicable. Okay. Even in this case, okay, Girish Ratnala, sir, if R is equal to 0, yes, that's what I'm explaining, Girish. Listen, here in this case, they had given one good condition. The good condition is D is not negligible compared to Y. Okay, in this case, D is not negligible. Okay, so the electric field equation will become what? See, my electric field equation stops here. If you remember, my electric field equation stops here before neglecting A. Before neglecting A, it stops here. So guys, are you listening here? Please listen. This is very important. This point is very important. I hope everyone is listening. Girish Ratnala, this is the answer. So what's happened? So many guys tried write R is equal to 0. So R, even though R is equal to 0, what happens if R is equal to 0 in this case? Guys, put R is equal to 0, R is equal to n, and R is equal to infinity in this case. Yes, my D exists. My D exists. According to the question they had given that D is not negligible. Given that D is not negligible, my expression for electric field will become E is equals to Kp by Y D square by 4 whole power 3 by 2. Now, even though my Y becomes 0, yes. No, Hari Prasad, listen. At R is equals to infinity, yes, correct. My E will become infinity. Correct. But it won't, I mean, E will become 0, but it tends to 0. My R never goes to infinity. My R tends to infinity. Okay, I should say R tends to infinity, not equals to infinity. R tends to infinity, it can never go to infinity because we don't know what is infinity. Sir, why is R 0? Girish, it's condition, okay. I'm just checking. So these, you have to check for three conditions whenever you get a graph. First condition is R equals 0. Second condition is R equals to some n value. Third condition is R tends to infinity. These three conditions you have to check whenever you get a graph. Okay. So if I check for each condition, when R equals 0, my D is not 0. So my E is some fixed value. E is fixed value. E is a fixed value. Then as my R increases, what happens? My electric field E decreases. Guys, are you getting this? Using this expression, E is equals to minus Kp by 4 y square plus d square by 4 whole power 3 by 2. This is nothing but E is equals to minus k times of P by R square plus A square whole power 3 by 2. This is the condition which we are using. Here A value is 1 by 4. Oh, sorry, actually 1 by 2. If or here it is D by 2. A is nothing but 2A is nothing but D, and A is equals to D by 2. Okay. Please reply guys. Please reply if you are getting this. Don't sit idle. I feel like you guys might be sleeping there. Are you sleeping? ಯಾರು ನಿದ್ದೆ ಮಾಡ್ತಿಲ್ಲ. Okay. See. Yeah. So if I'm substituting A as D by 2 and R equals to Y in this question, in this expression, I'll get this as my answer. So if you compare this, what would I get at R equals to 0? If R equals to 0, my electric field will be some E, right? Electric field will be a fixed value, right? As my R increases, my electric field decreases, right? As my R increases, electric field decreases. That's represented here. As my R tends to infinity, we should consider the third condition as R tends to infinity. R will never be equal to infinity. Hari Prasad, please note this. R tends to infinity. So as R tends to infinity, or here in this case, as Y tends to infinity, magnitude of electric field tends to 0. E tends to 0, but E never touches 0. So this is a graph of. So which graph is this? Which graph is this? So this is the graph. So option B is the right answer, guys. Hope all of you have got this. Hope all of you have got this. Please click on yes if you have got this. Let me know if you have any doubts. Let me know if there is any doubts or confusion. Okay, cool. Option B is the right answer. How I have presented here. Always check for three conditions. R equals to 0. First condition is R equals 0. Second condition, R increases. Third condition, R tends to infinity whenever you get the graph. Okay, guys. So hope you have got this. Now try to answer this question. So there are two charges of plus 20 microcoulomb and minus 20 microcoulomb and are held at a separation of 1 centimeters apart. Calculate the magnitude of electric field at a point on the equatorial line at a distance of 50 centimeter. So what are given here? So check what are given. So you have Q is equals to plus 20 microcoulombs and A is equals to, or 2A is equals to 1 centimeters. So R is equals to 50 centimeters along equatorial line. So they are asking you to find the electric field. What is electric field? So which formula are you going to use, guys? Neglecting A or without neglecting A? Can I neglect A in this case? Is my R very, very big than A? Yes, we can neglect A. Then try to calculate. E is equals to. So try to calculate and answer this, guys. Answer ಮಾಡಬೇಕು ಎಲ್ಲರೂ. Everyone should answer. Yes, we have to neglect A in this case. Why? See, 50 centimeters is very huge quantity compared to 1 centimeter, right? Compared to 1 centimeter, 50 centimeter is very big. So R is very, very big than A, greater than A. So we can neglect A. So without neglecting A will be the case, they will mention, see, without neglecting A, it will be like 5 centimeters and 1 centimeter. We can't neglect A here. Hariprasad, I hope you get the difference. Okay, you can calculate without neglecting A also. It won't make such much of difference in the answer. In the final answer, you'll get the same amount of, same amount of force, same amount of electric field. Okay. So here we are going to use the formula with neglecting A. Guys, I'm expecting someone to answer. There's no answer so far. So you want the equation is equals to minus kp by r cube. R cube, right? E is equal to minus kp by r cube. This is my equation which I have got. Please try to solve, and yes, I've started to receive the right answer now. Guys, see, problem solving is the main part in your J mains. See, though you may get many questions, but problem solving is the right part. Main part in your J mains. Please try to solve your problems. Solve all the problems which we have mentioned here. Correct, Ramakrishna Reddy? Ramakrishna Reddy, correct answer. Others try to answer. Girish Ratnala, correct. Nitya, check your answer. Suprita, check your answer. Sukesh, correct. Dhanush, check your answer. Sukeshini, okay, Sukeshini, correct. Guys, please try to answer. So you have to answer in your polls. Lakshmi, correct. Hari Prasad, correct. Ramakrishna Reddy, correct. Dhanush, no. Check your answer. ಯಾಕ್ರಪ್ಪ ನಮ್ಮ ಮಕ್ಳಿಂಗೆ ಎಲ್ಲ ತಪ್ಪು ಮಾಡ್ತೀರಾ, ಯಾಕೆ, ಏನಾಯ್ತು? ಪ್ರಜ್ವಲ್, ಚೆಕ್ your ಆನ್ಸರ್. ತುಂಬಾ ಕಷ್ಟ ಇದೆ ಇದು. ಸುಪ್ರೀತಾ, ಚೆಕ್ your ಆನ್ಸರ್. ನೋ. Guys, I'm feeling afraid now. You're making me feel fearful. Dhanush, correct. ನಂಗೆ ಭಯ ಆಗ್ತಿದೆ ಈಗ, ನೀವು ಹೀಗೆಲ್ಲ ನಂಗೆ ಏನಾಯ್ತು? ತುಂಬಾ ಕಷ್ಟ ಇದೆಯಾ? Do you feel this is difficult, guys? Guys, do you feel it's difficult? Prakash, no. Check your answer. Mega, correct. So guys, please let me know if this is being difficult for you. Is it anywhere? So let's try to solve. Okay, what is the value of k, guys? See, since we need only the magnitude, so I'm neglecting this negative sign. Okay, so I'll try to take 9 into 10 power 9, and dipole p is equals to q times of 2a, right? Q times p is q times of 2a. Okay, what is my q? What is my q? Q is 20 microcoulombs. So 20 into 10 power minus 6 into a. What is my a? Okay, it's 2a. 2a is 1 centimeter. 1 into 10 power minus 2 divided by, what is r cube? 50. 50, right? 50 into 10 power minus 2 whole square. Okay, to solve ಮಾಡಿ ಏನಾಗುತ್ತೆ guys? Why try to solve this much? So see, only 7 people have answered, and out of that only 4 people have given me the right answer, guys, so far in Zoom. So 9 to the 18. Oh, okay, sorry. Thank you. Whole cube. Yes, this is whole cube. Devikarani, correct. Lakshmi, Vikita, I didn't get. Irish Ratnala, yes, correct answer, Irish. Yeah, yes. Centi means 10 power minus 2, right? Hari Prasad, centi means 10 power minus 2. So, okay, yeah, even that's no. See, you are multiplying up 10, 100 into say if you are multiplying 10 into 10, 1 by 10, you will get 1, right? Hariprasad, check that powers, check your powers. They just correct. So guys, come on, I'll solve for you. 9 minus 6 is 3, 3 minus 2 is 1 by 5 into, okay, 5 5s are 25, right? 50 square. So 50 square is 25. I'll try to simplify first, then I'll square. 5 into 10 power minus 1 whole square. So what would I get? E is equals to 18, 180. Okay, I'll do this 180 by 5 into 10 power minus 1 whole square. So this is nothing but 180 by 25 into 10 power minus 2. So try to solve this, guys. 18 by 25 into 10 power. So plus 1 by 10 power minus 2. So this should be 10 power plus 3. Yes, correct, Lakshmi. Okay, 18 by 25 into 10 power plus 3 not plus 4. 9 minus 6, 3, 3 into, okay. This was 20, right? 180. Okay, again, I will be having into 10 power. 2 nines are 18. 20 into 9 is 180. 180 into 10 power minus 1. 9, 6, 10 power plus 1. Okay, cube alwa. Sorry. Okay, I forgot that. 180 into 10 power 1 by 5 into 5, 25. 25 5s are 125. This 125 into 10 power minus 3. Guys, try to simplify this. This electric field E is equals to 180 by 125 into 10 power 4. So what is 180 by 125? Guys, help me solve this. This should be equals to E is equals to 1.44 into 10 power plus 4. So this is the expression for, this is the answer for electric field, that is option D. Yeah. Yes, thank you guys. Cool. So got this. Hope everyone have got this. Yes. Cool. So I'm going to end the poll. Yes, most of you have got this, and that's great. So what's next? So we have potential due to electric dipole, guys. Next derivation we have potential due to electric dipole. So at a point on the axis of the electric dipole. So guys, you can try to solve it right now. Start its derivation. So what is the potential due to an electric dipole? So at a point on the axis of electric dipole. So I have, so what's given here? I have 2 point charges plus q and minus q. I have basically I have a dipole separated by a distance of 2a. Now this distance, so this dipole, okay, having a dipole moment p from left from right to left. Now I'll consider a point r from mid at a distance of small r from the midpoint again. So what is the general expression? So guys, try to find what is the electric potential due to electric dipole at point r. So guys, this for this question, no, for this derivation, you have a very tedious derivation in your CBSE. So I wanted to give you a simple derivation. So try to follow this derivation. Okay, but I don't know if you can write this in your exams, because in your exams you have but what to say, in your exams you will be having, you have to write it in a lengthy way, but this expression whatever we have is very simple. Okay, so the general expression for electric potential is given by V is equals to Q by 4 pi epsilon naught R. Then the net potential on the point R. So what is the so first what we have to consider here to derive the expression for dipole, when potential for dipole on the axial point. Okay, it's V is equals to Q by 4 pi epsilon naught, right? The general expression. So if we have a point charge, say I have a point charge Q at some point, I wanted to find its potential. How do I find? Apply this formula. V is equals to Q by 4 pi epsilon naught R, right? Correct? Now do the same. Do the same for these two charges. Say I have charge Q plus Q and minus Q. Do the same for these two charges at this point R. Find the potential due to this point charge on this point R. Say I have considered the potential due to the point charge minus Q to be V1 and the potential due to point charge plus Q to be V2 of the dipole. Now what happens to V net? V net will be equals to V1 plus V2, right? Now guys, everyone take some time, try to derive the expression. Okay, try to derive the expression for this. Cool. So try to derive the expression and let me know. Yes, I need the end answer. What's the end answer? So you guys could try to answer, I mean, try to solve this electric potential derivation. So guys, today's class was more about derivations. So if you are well aware of the derivations, I can skip these. Yes. So we have two more derivations in this case. But yeah, but this is mandatory part. We have to complete this. So derivations in a physical class, it would be good. I don't know how far. If you guys are solving along with me, the derivations, when you guys could enjoy that. I mean, yeah, you guys could solve along with me. But I don't know how you guys are doing that. So cool, guys. Then yeah, I hope everyone are trying to solve the expression for VNet net potential at this. So I want VNet at this point. Guys, come on, solve this. Come on, solve this. Yes. So guys, come on. If V is equals to KQ, okay. If V is equals to KQ by R is the general expression we know. What is V1? What is V1, guys? What is V1 because of this minus Q charge? Tell me what is V1? It's minus Q by 4 pi epsilon naught into what is my distance R, guys? What is my distance R? It's from here till here. Excuse me. What's my distance R? Yes, it's correct. It's R plus C. So this is my V1. Similarly, what is my V2? V2 is plus Q by 4 pi epsilon naught into R minus A, right? R plus A or R minus A? It's R minus A. Now add these two, you will get the answer. Add these two, you will get the net potential. Okay, that's what we have to do here. Okay, so what I did, I added these two. So V net is equals to my K minus Q by R plus A plus K plus Q by R minus A. So try to simplify them. KQ is taken as common. Yes. Okay. Okay, correct, Vinay. Sorry, correct, Tejas. Tejas had got this answer. So put Q is equals to Q times of 2A is equals to P, you'll get the answer for V net. So we have completed till the net potential of electric dipole for along the axis of dipole. Okay, so guys, got this? Got this? ಅರ್ಥ ಆಗಿದೆಯಾ ಇದು? ಈ ಸಲ couple ನಮ್ದೆ. So if we consider, okay, again, if we consider r is much more greater than a, then my net potential is this. So we'll discuss this again, guys. So we'll discuss this and this derivation again in our next class. So cool, guys, then we'll meet again. Yeah, coming to the doubts of Hari Prasad. Hari Prasad, you had a doubt, right? I forgot. Hari Prasad, you had a doubt. Excuse me. Hi Hari Prasad. I hope you are still available. So I got your doubt, Hari Prasad. So what I was discussing is, say if we have 2 point charges, I have 2 point charges plus Q and one more plus Q, say of maybe same magnitude or different magnitude. Now when they are separated by a distance r, then the electric field due to these 2 point charges was given by E is equals to K Q, or sorry, it's KQ by R square, right? Electric field due to point charges. Point charges is given like this. Now, if I have a dipole, okay, your doubt was clear. Okay, I'll continue. If there were dipole of same charges of same magnitude but opposite sign and separated by distance 2a, at a point and at a point on the axis, if I want to find the electric field E, then the electric field E was given by K Q, or sorry, K times P by 4 pi by R cube, I guess. So this was thing. So here, if you see, my electric field E was inversely proportional to that of R cube, and here my electric field E was inversely proportional to R square. Now, as my R increases, my electric field decreases, right? In both the cases, it decreases. But in case of dipole, it decreases fastest. That's what I meant. The electric field decreases the fastest, not the dipole. Hope, yeah. Okay, it's clear. Cool. Thank you. Okay, guys. Then we'll meet again tomorrow. Uh, then we'll see you guys again later. Then. Bye, guys. Okay, thanks, Vinay, for all the help. Uh, okay, guys. Then we'll see in tomorrow's class.